Sometimes I do that.
Sometimes you do that, so I didn't say anything.
So if you're talking about the first term in the sequence, that's a sub 1. If you're talking about an arbitrary term in the sequence, that's a sub n. And then you would define n however you want. So that's what this formula is representing. This is some term, the nth term. You can use it for any term you want, like a formula. This is the first term. Because it's a sub 1. This, d, is called the common, whoops, can't spell common, difference. The common difference can be a positive number, but it can also be a negative number.
Wait, the a to the n is the nth term?
The nth term, like the actual term. So in this case, like maybe like 38, like a sub 5.
No, we're doing this in physics right now.
Cool. N
cool.
is the term number. So in this example, how many seats are in the 5th row? 5 would be n, because that's the term number that you're looking for.
And then minus 1 is just minus 1.
Right, and that's we have to subtract 1 because
there's a number
you're starting with the first number and you're adding the common difference a certain number of times. You're not including that first number. So it's always minus 1, because otherwise you're getting to that. You're getting too far. Go to the next one. Okay. So first term plus your common difference. And if your common difference is negative, then it's just like adding the negative or subtracting. And then n minus 1 times. So you can use this for all arithmetic sequences. Not all sequences are arithmetic. In order for it to be an arithmetic sequence, you have to be either adding the same number every single time to get to the next term, or subtracting the same number. So if it was like 30, 28, 26, 24, okay, that qualifies as an arithmetic sequence because we are subtracting the same number over and over to get to the next term. Okay, but if you're adding different numbers, then it doesn't work out. No, I can't really.
Some rumors over habit, I was like,
Okay. Find the 50th term in the sequence. So first, we have to identify the common difference, or what we're adding or subtracting.
I'm on
minus
it.
5.
It's going down, so subtracting 5. That's what we're doing.
Boy. Oh, and it's a bigger number.
So D
bosom.
is negative 5. Not 5, but negative 5, because the numbers are decreasing.
Wait, I need to write down.
This is our arithmetic sequence formula. So since we're looking for the 50th term, we are finding a sub 50. The first term is a sub 1. What's our first term?
18.
Exactly. So that's going to go here.
Wait, does it start from 18, or we just assume that it goes backwards? I mean up.
It's
there.
so if there's numbers before it, it'll have a dot 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 before it, like this.
And in that way, you would just like it would be plus 5.
Well, you'd have to find it. Like you have to start with the first term. So a sequence, hold on. So a sequence starts with a number and then it goes on forever in one direction. It doesn't go that way.
Can it go both ways?
No.
Because like if it goes
It
like 18,
can
if
you're talking about if you're starting it, like if I say this is like a sub 10 and then somewhere all the way over here is a sub 1, but there's always a first term.
Okay.
So think of it like time, like it starts, well, I mean, I don't know if that's a good example. Think of it as like time at an initial moment. Like we started class at 8 a.m. and then class keeps going.
Okay.
I don't know. Then maybe it's not.
I understand.
Because like time kind of goes back, but like.
But like,
What?
does it? We don't have time machines.
I know. I was gonna say that theoretical.
Not worried
too
about
much.
it.
All right. Anyways, moving on.
You
So
can't go
our
back in
common
time.
difference
You
is
only go
negative
forward.
5. So we're gonna do minus 5.
Can I be plus minus 5 just because like?
I know, but that's awkward. So I just left out the plus.
I'm just gonna do it.
And then we're gonna do this 50 minus 1 times. Now, without using a calculator, there's 2 ways that you can simplify this. The first way is by distributing.
Ew.
They're super brooding.
Okay. The second way is by using PEMDAS, which means you would combine these, okay, and then you would multiply. What is that? 5 times 50 would be 250. So that's gonna be 245.
I'm
Okay,
just gonna
if you
distribute.
do it this way, then you just kinda like add and subtract left to right. So I don't know, that'd be like negative 132 plus 5.
What?
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 Isn't it?
No.
No,
232.
72. No.
No,
Yeah.
it's
Wait,
definitely still
232.
200 something.
232.
It's definitely
I
still
was-
200
what?
something. It's like,
Yeah. And then add 5, and so that's negative 227.
Thank
This
you.
should also be negative 220.
I would hope so.
It's negative.
What you don't want to do. Wait. Oh, this.
How?
Wait.
What? No, I was joking.
What you don't want to do, and I see this a lot, is you don't want to subtract here. So a lot of people do like
I was
18
gonna do
minus
that.
5, and
Yeah, I
they
gotta
get
do that.
13, and then they multiply. But see, that can't happen because then you're subtracting before you multiply. You always want to
Yeah.
make sure you do PEMDAS. The only exception to PEMDAS is if you use the distributive property, which is a property that we're allowed to do. Okay, but you can't like make up your own properties, which say I can do this and then that. That's like making math up. You don't want to do that.
If PEMDAS was in a different order, would all math problems have a different answer?
Yes.
Then who created PEMDAS?
What
And
if
why
it
is
was-
that
The sequence
finding-
goes something like this. First term is 4, the second term is 13, and then it's going to continue.
How do you know
Okay.
that it's 113?
Oh, because I added 9.
Oh, that's what the 9
And
is.
somewhere in the future is 184. We want to know what term that is. We know the first term is 4, and we know the common difference. So we could just sit there, like maybe with a calculator, and keep adding 9, and then like count how many times we added 9.
That's what I would do.
Yeah, right. That's probably what you're gonna do like on the SAT when you forget all of this. But we're not gonna do that. We're gonna use our formula. So we're using this formula.
That's so true though.
We're just gonna use it in reverse.
Wait, what is?
So in this case, we know our nth term. So 184 is our nth term. That's gonna go on the left.
Oh my god.
That's what we're trying to get to.
And A is 4.
A sub 1, is 4.
And then D is 9.
D
I just
is
wrote
9. And we're seeking n, which is where this is in the sequence. Maybe it's like the 50th term, or maybe it's the 20th term.
So are you able to add the 4 plus 9 and then divide?
No, you have to distribute the 9.
So your options are, you can either distribute the
Oh,
9
got it.
or you can subtract 4 from both sides.
Right.
And then after subtracting 4, you can divide the 9.
Oh.
Or you can distribute the 9. It's
I
up
like
to you.
dividing.
I'm gonna divide by 9
because
because
you
I
get
think
20.
it's easier.
Yeah, 20 is like such a nice number.
And you get plus 1.
And then you add 1, and you get 21. So that means that 184 is the 21st term. Or
It isn't hard to just
A sub 21 is 184.
Does
This
it
is
matter
like,
which way we write it?
I was just gonna say, this is like the math symbol way, and this is like the
I like the
English
math
word
symbol
way.
because I can't speak English.
Yeah. But basically the same idea. So no, you can't, just in general, like remember that you can't add those. If it's gonna help, maybe write it differently, like you can always write it like this. And then you wouldn't maybe think to add them. Remember, this is just like a variation of that. And you wouldn't think to add D and A sub 1 in that situation. But just because they're right next to each other doesn't mean you want to add them. Try the U-track.
You telling me it's not?
Oh, 100%. The most thing you should.
Okay, this is the second term, third
Not
term,
my fault.
fourth term, and then our fifth term is 14. And we want to know what the first term is. So we're going to use some problem solving skills. Now our formula here,
Mine was. I mean, it was like cheap, but there was more.
okay, our formula can be rearranged to fit other situations where we don't necessarily have the first term. So it can be tweaked.
Ew,
In this
18.
situation, we don't have the first term, we have the second term. So what we can do is vary this a little bit so that this says A sub 2. And then we would change this, to 2.
Oh.
And we
I
can
know,
kind of do
wait.
that whenever. Like, we can change that to a 3 or a 4 or whatever, as long as we change the number that goes here. Because if you think about it, the reason it was -1 is because you were subtracting that, because there was like one term there. So if you're starting with the second term, then you would have to only add a certain number of times. And so we can use this to figure out maybe what our common difference is. So let's see what happens. We have,
Isn't it 3?
oh, maybe, let's see. We have 14
No, I lied.
as a sub n.
It's not
We have
3.
8 as our second term. We don't know our common difference, but we do know that n in this case is 5.
Oh.
So in this situation, we're solving for the difference. We need to know what the common difference is in order for us to find like these missing
Why
terms.
is n 5? Because of the
Wait, so why did you subtract
So
2?
n is 5 because I used 14 for a sub n, so that makes
Oh,
n
okay.
5. And then a sub 2 I'm putting here, which means I have to put a 2 here.
It's definitely not 3. I like missed everything. It would have been 3 was like 8 and then 11 and then 14. But I missed one, so it's okay. It's actually 2.
We can like simplify this. So 5 minus 2 is 3.
I'm gonna subtract
Subtract 8, so that's 6. And this is 3d, or d times
So
3.
divide by 3.
Divide by 3, you get d equals 2.
Oh my god, I was right.
Now, in some situations when the pattern could be easy to spot, you could probably do it in your head. Sometimes not so much, so it's like helpful to know how to do it when it's not obvious.
And then A1 is
And so then we would
6.
apply this, right, so we would apply this if it's looking for the first term. Do we want this number to get bigger or smaller? Smaller, because it came before it, so this would be 6. Now if they asked what these were, what are these?
10, 12.
10 and 12, and does it make sense?
Yes, ma'am.
Yeah, it makes sense. So that's how you can check, just kind of like fill in some blanks. Make sure it's still an arithmetic sequence and they're still increasing or decreasing by the same number over and over again. Okay. See if you can do that, you will try. Arithmetic mean is like the mean that you guys are just normally used to finding, like a regular average, right? So if you got like a 50 on a test and then you got a 60 on a test, what's your arithmetic mean?
55.
55. You just add them up and divide by 2. That's what an arithmetic mean
This
is.
is the same lesson, right?
Yep, same lesson. We use arithmetic means to find like.
Wait, hold on, I'm sorry. The
Specific.
second part.
Oh, sorry.
I need to read, like this.
Bless you.
So we could use arithmetic means to find missing terms, but not like in the last one where there were like 2 spaces, when we're looking for maybe 1 space in between, or like the middle. So we use arithmetic mean when we're finding the middle. We couldn't use arithmetic mean in the last question because there wasn't a middle, because the middle was like in between terms.
Wait, but why did you
So if you see
multiply
like,
by 2?
see like how we didn't have the middle was like here, it was in between terms. We can't use arithmetic mean. But in this case, we do have a middle. Why did I multiply by 2?
She's talking about the other problem.
No,
'Cause
this
we were
one,
we
right
were
there.
here.
Yeah.
We were here, and we needed to go back to the first term. So I can't just add 10/3 once, I have to add 10/3 twice to get back to the beginning.
It's just like awkward. Oh, either. I just like feel dumb doing this because it looks easy, but in reality, I just can't do it.
No, I'd be like the idiot that would sit there and like add 15 if I was
Great. So what we're gonna do is we're gonna find the missing term in between these 2 terms using our arithmetic mean. So we're just gonna find the average of 15 and 59. We add
One's Y.
15 and 59 and divide by 2.
So is it always gonna give us 2 numbers and that will be our X and Y, or can we just choose any of the numbers in between?
So you can do this for any time it's in the middle. So even if you had like, I don't know, like 2, 1, 2, 3, like, I don't know, 10. You can find this middle using the same thing.
But that doesn't have a middle because there's 4.
But we're finding this middle. So we're finding the
Oh,
second.
we're finding that one and then just add the next.
Yeah.
Okay, cool, got it. Don't mind me. Sorry.
So this is gonna be 64 over 2, which is 32. So that's this number.
How is it 64? I thought it'd be 74.
No, it's 60.
No,
Oh wait,
it's
no,
77.
it's 74.
Oh yeah.
Thanks, Kath.
You're welcome.
Okay, so that's 37.
Yeah, that's a grosser number though. We should have just
Sorry.
left it.
No, that's not how math works. You don't get to leave the wrong answer.
And then
So now you're just gonna
So easy.
observe the trend.
D is 22.
Okay, so we can find this number by just adding 22. So that's gonna be 81. Right? Kathleen, math check me.
Yeah.
Can I fact check you?
Yes.
Yes. And then if you wanna like super check, you
Hmm.
could like add these numbers and divide by 2 and make sure it's that number. If you wanna like make sure it's all.
I like this question over there.
I
so
tried,
glad.
you try.
So glad.